All right, so I'm going to talk about explainability and particularly error messages in Spack concretization. And so what is Spack? Mostly skip that because Todd talked about it earlier. How does Spack handle dependency resolution, and what is Clingo? We'll talk a little bit about that because I'm going to focus on different aspects than what Todd talked about. And then the problem with error messages from Clingo in Spack. Our first attempts at implementing the solver in Clingo led to some very lackluster error messages, and the rest of the talk will be setting up what the problem was and then what we've done to combat that and where the state of it is now. So, combinatorial package manager. Really the relevant thing for this is that the build space is more parameterized than in a lot of package managers. We're talking not just about names and versions, but name, version, compiler, compiler version, build options, per package options, etc. And the point is that that affects the choices that we have to make in what sort of solvers to use. So Todd talked a little bit about concretization. Right, this is how we get from a user request to the full metadata for something that we're going to build. And what we use for that is Clingo. As an ASP program, that means that effectively there's two stages in Clingo. There's the grounder and the solver. And the program is written in first order logic. That means we have access to variables if you've done any formal logic. And the grounder, called Gringo, takes that and turns it into SAT, or something very much like SAT. And then the grounded program can be solved using things like CDCL. And that's what the Clingo component clasp does. And one key element of Clingo that we rely on for this is that it offers optimization guarantees, where you can say, okay, give me the best model, and the first criteria for the best model is picks the newest versions, or whatever you want that top criteria to be. So what does Clingo code look like? So there's a little bit more than this in reality, but for what we want to talk about, there's really 5 types of statements in Clingo. You've got facts. There is some root package called zlib. There are rules, which generally operate on variables rather than on literals. So if you have a root package, it is also a node in your graph. And so the head of the rule comes first, and it is true if the body is true. The body can have multiple clauses or multiple statements. And then you can also have constraints. And constraints just look like a headless rule. And it just says you can't have a solution for which this is true. So you cannot have a solution in which there is a node and that node is not needed, where needed is defined somewhere else, but roughly, the user asked for it or something depended on it. Clingo also has choice rules. So you can say, if you have a package, pick a version from among the valid versions. And so that's what this is saying here. And then cardinality constraints look a lot like choice rules. You can pick one, but it's a constraint on how many you pick. And so constraints and cardinality constraints effectively become the error cases of your program. So what's the problem with error messages? Well, solvers generally tell you, either give you the model that solves it or tell you it's not solvable. And when you give this to a user and the user says Spack install HDF5 and they get an error message that says unsatisfiable, they have no idea what to do next. So what could we do from here? So the first thing we did is, if you're really clever, maybe you could think of this. We found it by asking the people who wrote ASP what to do. You can add a clause to these constraints, or add a clause to the rule body that says, if I have this sort of error, if this sort of error is true. And what that allows us to do is we can get out which error message was associated with the one that failed. So this gets us something a little better, but what package had the problem? Why did we even care about that package? It's not necessarily the thing we asked for. It's still not great. But this was enough that we were able to at least put things into production, and then we could just rely on other methods to debug it. So another thing that we tried is using unsatisfiable cores. So a common method, there's two common methods that I know of in solvers for how to get good error messages. One of them is proofs, and one of them is unsatisfiable cores, and it depends on the solver and what techniques they're using, which of those are available. So Clingo has options to get unsatisfiable cores, but the unsatisfiable cores are not necessarily minimal. There's no guarantee. In most cases, they're somewhat minimal. We actually used them even in this previous version. The unsat core, just considering the error messages, is actually how we figure out which one is relevant. So we tried to implement unsat cores over the entire problem, and found that in some cases our unsatisfiable core was something like 20,000 facts. And that might be even worse for the user than just saying it's unsatisfiable, because they think they're supposed to read 20,000 facts. We tried to minimize those. You can manually minimize, resolve, pulling things out, but that was taking 3-ish hours for the bad cases. That wasn't an option either. The other downside to unsatisfiable cores is that they're not actually that legible. So in this case, we have this sort of generalized condition in the way we've encoded our data that means that, okay, sure, I can read this. There's a root A. There's some condition. It's about dependencies. It imposes a version constraint. But it requires a lot of work to actually parse that into what went wrong here. So the solution that we've come to, part one, is to say, instead of having constraints on the logic solver, one of the things the logic solver can give us a model for is, here's the best model, it includes an error. So we took all of our integrity constraints in the program, right? You can see this is the same constraint we had earlier if we have a node and it's not needed. But we've made it a rule instead, and it derives an error with priority 1. And so I mentioned earlier, you can have optimizations in Clingo, and our top priority optimization is, if it's in any way possible, give us a model with no errors. If that's not possible, we'll get a model with errors, and now we can show those errors to the user. Now, the nice thing about this is that if we go back here, there was no good way to get the package into this error message, because we had to tell the program in advance that all of these errors were true. Right? We dynamically generate the program, and we had to say, all of these error messages are true facts, so that if the other things were true, it would trigger the constraint. So we couldn't do that for every possible way the error message could come up. Now, in this format, we can say, all right, the error message has a string and it's got a package. And you can see we're kind of abusing Python format strings. We get that back and we format it by the arguments. And then similarly for the cardinality constraints, we turn them into a choice rule. You can pick a version. You can pick however many versions you want. But if you don't pick one version, it's going to force you into one error message or the other. So this got us much nicer error messages. And so this was a major win for us like a year and a half ago. But it's still not really what we want. Because if I say Spack install Trilinos, and what I get back is zlib can't satisfy these two versions, that really doesn't tell me what to change. Why are we even thinking about zlib? Which packages depended on it? What other choices have I made that forced me into this condition? So what we really want is to be able to say, why are we picking these facts that also form this conflict? So to get to that, I'm going to back up for a second. How do we encode conditions in the Spack concretizer? So one of the things that we've done in the logic program that we've written is we have a generalized way of writing conditions. Lots of things in Spack are conditional. Todd talked about it earlier. We have all these when specs that we call them that because they come up in the Python as when equals blah, blah, blah. And by encoding them with a shared structure, we've made this much easier to reason about, easier for us to maintain. So you get a condition. The condition is, it has an ID, and it has requirements and imposed constraints. And you can think of this kind of the same as the rules in Clingo to begin with, right? They have a body and a head. If the body is true, the head becomes true. Well, we've split it out in Clingo, but it's still the same thing, right? If these two condition requirements are true, then the imposed constraint is true. And this is what that looks like in Clingo. These colons are conditional rule body elements that's saying if for every condition satisfying this arity, the equivalent attribute is true, then the condition holds. And if the condition holds, then we create attributes, facts that we assert are true for every constraint that it imposes. So instead of, here we had version, package, version. Here we're talking about attr, and then the first argument is version, and then the package and the version. And so we can translate between the two forms. So that brings me to part 2 of the solution. Getting the causal information among the conditions. Because everything is represented by these generalized conditions, if we can associate all of the conditions that went into a fact, we know why we're making that choice. So we say if a condition holds and imposes an attribute, the attribute's true. The attribute is a requirement for another condition, and the other condition holds, then the first condition was a cause of the second one. And then, as an implementation detail, we have to implement that for every possible arity of the rule, or of the attribute. So now we can write more complicated error messages. We can say, okay, I've got an error if I have a version and that version was imposed by some cause, and that cause is actually true. And I've got another version and its cause. Now I can give you a much more detailed error message. I can say, these two versions conflict, and here's the reasons that they're in the solve to begin with. So here we can say, all right, concretization failed for the following reasons. I should have left in. This is Spack install HDF5 depends on CMake at 3.0.1. So picking intentionally an old CMake that I know won't work with HDF5. And we get out, okay, it can't satisfy that combination. 3.0.1 is required because it came in from the command line. And 3.12 or later is required because HDF5 has a rule that it depends on CMake with that version constraint. And HDF5 is required because it came in from the command line. So we can generate these trees. And I truncated the output a bit, right? You start to see multiple of these sorts of errors pop up at the same time. So there's also a conflict with an even newer CMake that got pulled in, etc. So then part 3 of the solution is performance. So I prototyped this maybe a year ago. I had it performing well. Lots of changes in the concretizer that had happened since that Todd mostly talked about earlier. And I went and re-implemented it, and roughly 20x slowdowns across the board. You can see that this is a log scale plot on the top. It's the setup phase, which didn't change because that's the Python side. And then the grounder and the solver, and then the total. And the orange is the pull request, the blue is the original. And not only was it 20 times slower, but it also would get worse every time you added a new error message, because it had to associate the causes, any possible cause with any possible error message. So that was a non-starter, performance-wise. And we re-implemented it as a post-processing. So we keep the non-causal error messages that I showed earlier. We run the solver that way, and we get the optimal model. And because there's equivalent error messages for the causal and non-causal forms, we've still got the same optimal model. We take all the facts from the optimal model, and we do a new solve with the optimal model and the rules to figure out the causal relationships. But we only have to do that if there's an error. If there's no error, great, we're done. And even if there was an error, we only have to operate on this much smaller, right? We have to compute every possible causal, or consider every possible causation, but only for the actual errors that we've hit. So that's a linear scale plot of that below. It's roughly a 3% performance penalty for successful solves. And that's because I tweaked the model to turn more things into generalized conditions so that it was easier to trace through them. And another couple of percent, maybe in the 5 to 8% range for failed solves, because we also have to pay for this post-process solve. But instead of being 20x slower, it's just a very quick solve on a very restricted domain. So part 1 of the solution is implemented and is in Spack now. The pull request for parts 2 and 3 is going through code review at the moment. And it doesn't include every possible error message yet. The slowdown isn't scaling with the error messages anymore, so we're going to get the implementation in place, a couple error messages, and then work on figuring out how to tie the attributes for each error to their causes for the rest of the error messages. And that's it. If you want to follow up with us, You can get on Spack Slack. There's a link for that from our spack.io, or there's the direct link, or on our GitHub. You can ask for my email address. And if you want to follow the pull request, there's the number. That's it.
All right, we have a couple of minutes more to have questions and answers. Does anyone have a question for Gregory? Here we go.
I have to choose between two questions, but I'll just choose one. Would you? It's probably. I know that your work is in progress, kind of right now on Spack. But would you say that this? To me, I see quite a lot of work on especially making error messages possible, and that seems generalizable potentially to other users of Clingo. And I understand that's not kind of the goal of Spack. It's kind of to continue working on this. But do you think, or would you say it would ever be possible, or to consider like potentially upstreaming or making another library about these error messages? Because I've seen that be a positive thing before. Now that being said, I know it's not necessarily feasible right now. But do you think that's a reasonable thing, or do you think it's very problem specific? I think that's my question.
Yeah, it's the right question. There are a lot of projects based around Clingo, one of which is Clingo, which does something kind of like this. But with a performance penalty because it's kind of baked into the system. And because of the way that we have to deal with as a package manager, we have to deal with bootstrapping. It's not great for us to jump on all these little Clingo offshoots. The method that we used is something probably generalizable to other ASP programs or Clingo programs. We met with some folks from the POTASSCO project at Potsdam yesterday and talked about it. But the implementation has to be so specific to your problem space that you couldn't, because of the way ASP works, you can't really turn it into a library that someone else could use. You can show them the technique and advocate that it might be useful for them as well, but it kind of has to be done bespoke per project.
I'm just wondering if, because in the end, you show the problem with this ends up being performance, and so now you have to kind of do this only for those cases. And how far it wouldn't be possible to instead kind of modify your ASP solver to kind of keep track of this kind of information as it's solving? Like, did you consider that as opposed to trying to rewrite your programs?
Yes. So there's, right, the version of this sort of tracking that Clingo does is the unsatisfiable cores that we already couldn't use because in the worst case they blow up.
Well, I'm wondering if you modify the solver to actually keep track of information as it gets to the point of unsolvable, if you can't, then if you keep track of a certain level of what decisions have I made up until this point, can kind of reverse back through this and get to the same level of information as what your other program encodes.
Yeah. So, go ahead.
Yeah, you could. And I think there is I'm forgetting the name of it, but they mentioned that they have something that will sort of spit out the causation for all the deductions that got made for a particular solution. The issue I see with that is that there's a lot more going on in the solver than just the constraints that come in from the packages and all the preferences for the users, which is what those generalized constraints are. And so if you looked at the graph that Clingo gave you, it'd be really big, and it would have a bunch of other logic that's really control logic and stuff for the solve, in addition to the stuff that the user cares about. And so the fact that we're doing it just for the generalized conditions, I think is actually good. But yeah, I think you can do that. The sort of equivalent of that is how Z3 will spit out a proof for you, and you can try to reconstruct what the heck it was thinking, or why your problem is unsat, and it's not pretty. It's not, and it's hard to parse and yeah, I'm not sure how general you can make that with all the things you have to do to put a logic solve together. So yeah, and with CDCL, like in pubgrub, right? The way that they're tracking it is that they're looking at the back jumps that they do, but they sort of specifically know that they're dealing with versions, and so they track the back jumps around versions specifically. So they already have the semantics in mind. And I think, I mean, that's one of the nice things about pubgrub, but I mean, this is similar. It's just for like versions and options and flags and all that other stuff. So yes and no, I guess. I don't know, does that answer your question?
One thing that I ignored in talking about this is we didn't actually turn every error message into this. We turned the ones that would point to something that the user had made a choice about that they could change, and kept the ones that are like the fundamental structure of making it a DAG in the other format. So those don't pop up. And that kind of gets back to what Todd was saying, is you don't actually want to see everything.
All right. Unfortunately, we have to move on to the next talk. Thank you again. Give a round of applause.